Well, good morning. It's the physics video lecture once again, Physics 105A, video lecture 39. And this will be very short. I'm just announcing the final. I'll give a little bit of a heads up on what the problems are and anything else that comes to mind. So let's start with final exam. Is traditionally on Monday. This year it is May 10th. And 8:45 to 10:45. 45 a.m. I'll send it out a few minutes before. We'll try to get it in within a few minutes of that time. Good, so what's going to be on the exam? We're going to have a kinematics type of problem again, similar to what we had on the midterm, different one. Kinematics, some elementary interesting thing where we can take some derivatives and so forth, analyze what's going on there. The next one is going to be a dynamics problem, also of the type that we saw before. So we're looking at m dv dt is equal to some function of, say, position and velocity, or it could be just a function of velocity, function of position, of the type we did before. And one important type is the mv dv dx, right? In a one-dimensional problem, yeah, that's what I should have said here, one dimension. mv dv dx, that's your dv dt, right? And we use those under circumstances where we don't need to know about the time. We're just looking at position, velocity type of behavior results. Good, so that's similar to what we had last time. Then something where we have to do a quadrature. And by that I mean reducing this problem, which is already a first integral of the motion, right? We've used conservation of energy, and then we solve for dx dt equals 2 over m e minus u of x root, and we end up finding t integral of, something in terms of x. Separation of variables for the time. That can be a period of oscillations type of problem. It could just be a period of, or you can just end up solving for the time. Okay. So good, we have one of those. Shouldn't have written so large. Now the fourth problem, I want us to be able to solve one of these using the method with the complex numbers. So first of all, we reduce it to this form here, f of t over m, and then we solve, and then we had x turns out to be the imaginary part of c divided by omega naught. And we had a recipe for solving this, and it's just going to test your ability to go through with the complex numbers and the calculation. So yeah, I'll put the formula up here. E to the I omega naught t integral 0 to t dt prime f of t prime over m e to the minus I omega naught t plus a constant. So go ahead and review that. Review that material. So that's a good one. And finally, I guess I'm gonna have to erase something after all. Now we'll put it right here. A central force problem. So here we want to say we have force F of R times unit vector, and suppose I give you the force. Then you know the drill. You go construct your potential energy, probably ask you to sketch the graph, construct your effective potential, find radius of circular orbits, and whatever else we can think of. Okay. Radius of circular orbit, apsidal angle, important, right? So we had a formula for that, or we had a definition. Yeah, we had the definition, but we also had the formula for general potential energies. So yeah, that really goes through the entire semester content. So these are the skills we need going into the next semester, so it's perfect. So let's see. That should be it. I'll be sending out an email soon discussing the next semester face-to-face that we're going to have, normal class again, recitation section, and other questions of interest. Let's see. So yeah, if we have Monday, May 10th, 8:45 to 10:45. And just let me know if you have any questions, but this is what you want to study up on. Good. See you guys then.